We're already on the last page of chi-squared problem sets, page 4. Number 7. Ayako had a part-time job working at a sushi restaurant. She calculated the average amount of sushi sold per week to be 2,000. She decided to find out if there was a relationship between day of the week and the amount of sushi sold. Her observations are given in the table. So you see, any topic can be a math studies IA if you do chi-squared, as you can see. Okay, so we have divided up the days into Monday through Wednesday, Thursday through Friday, and Saturday, Sunday. And then the days that sell between 1,700 and 2,300 sushi is here, and the day that sells less than 1,700 is here, and the more than 2,300 is here. Okay? Now remember, the actual data is in the middle, so that's this section here, and the totals you kind of ignore. All right. Now you're going to perform a chi-squared test at a 5% significance level to determine whether the amount of sushi sold is independent of the day of the week. State the null hypothesis. Okay. The null hypothesis, H0, is equal to the two categories are independent. So we could say day of the week and sushi sold is independent. Okay? As usual, I spelled independent wrong. Pendant. Typed it wrong, at least. All right. And then, of course, they want the alternative hypothesis, which is H sub 1. And you're going to put day of the week and sushi sold is not independent. Please do not write dependent, because that is something else entirely. Okay, that's like saying that they cause each other, and we're not saying that. It might be a coincidence. Show that the expected frequency of selling over 2,300 sushi on Monday through Wednesday is 52.4. So let's see. Over 2,300 sushi per week is right there, the right column. And Monday, Wednesday is here, right? So let's see. The subtotals for those weeks are here and here, and there's the total. So we're going to use those numbers to calculate that it's 52.4. The way we do that is we're going to calculate this 170 divided by 470 times 145 times 470 times 470 is going to be equal to the expected frequency, which we don't know what it is yet, right? So 170 divided by 470 times 145 times 470 times 470 is equal to, let's see, 170 times, and we'll do this on an offline calculator, which is much faster to type on. Gives us 52.4. What do you know? Okay? That's right. Okay, so we've shown it by setting up this equation. All right. Write down the number of degrees of freedom. Well, that's easily calculated, right? If we tried to construct a matrix like this, we could choose a maximum of 4 values, and the remaining values would be automatically calculated from the values we already chose. So you could see that the number of degrees of freedom is 2 by 2. 2 times 2 equals 4, right? The way you get that is m minus 1, number of rows minus n minus 1, number of columns minus 1, and that equals 4, okay? Because it would be 3 by 3, but you subtract 1 from each one, so it's 2 by 2 equals 4. Write down the chi-squared value for the data. Now you need to put this data into the calculator, and we're going to do that with second matrix. And we're going to go to, let's just use A and B. And then, oops, did that wrong. Second matrix, and then we go into edit, and then we go into A. If you haven't done it for a couple days, then you might already forget how to do it, just like I did there. And then I'm going to put all the numbers in. So the first one's 38, and then that next one's 39. And I'm not going to make you watch this whole boring data input. Okay, you can see I've put all the data into matrix A. And then I'm going to do a stat test and go to option C. Sometimes it's faster to go from the bottom. And I'm going to put that the first matrix, the observed data, is going to be in matrix A. And then the expected data I'm going to put in matrix B, or the calculator is going to put it in matrix B, but I'm just saying where to put it. Then I press calculate and it gives me these values, one of which they're asking for, right? They're saying write down the chi-squared value. The chi-squared value is right there, 1.83. And then they tell us that the critical value is 9.488. So is 1.83 the chi-squared value greater than the critical value, 9.488? No, it's not. So we do not reject the null hypothesis because the chi-squared value is smaller than the critical value. Okay? Moving on to the last problem, number 8. Haruna wanted to investigate the connection between the weight of dogs and the weight of their puppies. Her observed results are given in the table, and so the two categories are dogs and puppies. Perform a chi-square test at the 1% significance level to determine whether a puppy's weight is independent of its parent's weight. So the null hypothesis would be that the two categories are independent, so we would say the null hypothesis, oops, I keep typing the wrong keyboard, the null hypothesis is equal to the two categories are independent, so dog weight is not, and their puppy's weight is not, or is independent. And then the alternative hypothesis would be the opposite. Dog weight and their puppy's weight is not independent. Okay, as usual, I misspelled or mistyped independent. Okay? Alright, but you understand. Show the expected frequency of a medium dog having a heavy puppy is 13.4. Okay, so to do this, we choose medium dog and heavy puppy, and then we're going to multiply those subtotals together. So there's the 46 subtotal that goes with medium, the 41 subtotal that goes with heavy puppy, and then the 141 total, which we're also going to use. So we're going to multiply 41 divided by 141 multiplied by 46 divided by 141 times 141. And so we could also just cancel those two out. We'll left with 141 in the denominator. So we do 41 times 46 divided by 141. And that gives us 13.4, which is exactly what they said. Okay? And if we were to find the expected values, then this position here would be 13.4, which would be dog medium and puppy heavy. Okay? Alright, let's move down. Write down the numbers of degrees of freedom. Okay, so there is a 3 by 3 matrix. So 3 by 3 matrix, we're going to subtract 1 from the rows, subtract 1 from the columns. We're going to get 2 by 2, and that's equal to 4. Right? Write down the chi-squared value for this data. The chi-squared value, we're going to have to type in all these numbers into the calculator. Let's put it in C and D. C. Oops, did it wrong again. Second matrix, edit. Then I go to C. And then I change it to a 3 by 3 matrix because that's what it is. And then I need to type in all these numbers. And the first one is 23. And the second one is 10. And I'm not going to make you watch all. Okay, so here is the input data into C, and if I go to run the stat test, go up to option C, which is chi-squared test, then I'm going to put C and D here. So second, matrix, name, C, and then I'm going to put in the expected second, matrix, name, D, and then I calculate. Okay, and then I get all these numbers. So I'm going to write these down. Chi-squared is equal to 13.7. The p-value, we're not going to really use this too much, but some of you advanced students might be curious about it. And then we're going to check the D matrix, which we can do by going down to names and clicking D. And there's the D matrix. Now you can see that the value that we calculated manually, 13.4, it's right there. It's 13.38. So yeah, that's 13.4. Okay. Now the degrees of freedom we calculated, chi-squared, it's right there. And then it says the critical value is 13.277. Using the critical value or the p-value, comment on your result. Okay, we'll do both on this one since it's the last one. So remember, the chi-squared value we compare to see if it's greater than the critical value. Okay, and the p-value we compare to see if it's less than the significance level. Okay, so we'll do both of those and we'll show that both of them work out. Especially this is such a close call, you're probably interested in seeing what happens. So chi-squared is 13.7. They're asking, is it bigger than 13.277? And the answer is no, right? And what about the p-value? The p-value is 0.00832. Is it less than the significance level? The significance level is 1%. Converting to decimal, 0.01. Is 0.008 less than 0.01? Yeah, it's barely less than 0.01. So also, no. Both should always give you the same answer of no, okay? And then you say, okay, since they're both no, then we do not reject the null hypothesis. And that's it.